welcome to Learn Mathematics. In this video I am going to solve a question. The question is from real analysis. The question was there in CISR UGC in 8 June 2011. The question is, let I equals to 1 union 2 be a subset of R, and for x belongs to R, let define phi x is equals to distance between x and I. The distance between x and I is given by infimum of mod of x minus I such that y belongs to I. Then which one option is correct? The first option is phi is discontinuous somewhere on R. Second option is phi is continuous on R but not differentiable only at x equals to 1. Third option is phi is continuous on R but not differentiable only at x equals to 1 and x equals to 2. And fourth option is phi is continuous on R but not differentiable only at x equals to 1, x equals to 3 by 2 and x equals to 2. So let's try to solve this problem. So before we can solve this problem, we have to understand the problem. It is given that I equals to 1 union 2 and subset of R. That means I contains only two elements and those elements are 1 and 2. And it is given a function. We have defined a function phi from R to R, and it is defined by phi x is equals to infimum of modulus of x minus y such that y belongs to I. This is our definition. Now since I contains only two elements, then there are two elements of this type, so we can say this is actually equivalent to infimum of mod of x minus 1 and mod of x minus 2, infimum of these two. Now we can find the value of phi x using two cases. Case 1, for case 1, when is x is less equals to 3 by 2, when x is less equals to 3 by 2, if x is less equals to 3 by 2, then mod of x minus 1 is actually less equals to mod of x minus 2. So in this case we can say that phi x is infimum of mod of x minus 1 mod of x minus 2, which is equals to mod of x minus 1. And case 2 is x is greater than 3 by 2. So in this case we can see that mod of x minus 1 is actually greater or equals to mod of x minus 2. So we can say that phi x is equals to infimum of modulus of x minus 1 modulus of x minus 2. So since mod of x minus 2 always less equals to mod of x minus 1, we can say this is actually equals to mod of x minus 2. So the given function phi x can be given by phi x is equals to x mod of x minus 1 when x is less equals to 3 by 2 and mod of x minus 2 when x is greater than 3 by 2. So we should try to sketch the graph, and then using that graph we are going to tell which option is correct. So how can we graph this function? First of all, we know that the graph of mod x looks like a V. Mod x looks like a V. So if we graph mod x, if we try to graph mod x, so this is how it looks like. Passes through 0, but it is never negative, and it looks like this. So this is our mod x graph. Now in this case we want to graph mod of x minus 1 for x less equals to 3 by 2 and mod of x minus 2 for x equals to 3 by 2. So to graph mod of x minus 1, we have to shift this graph 1 unit to the right. So if we shift, let's try to sketch the graph. So this is our y-axis. Now if we try to sketch the graph, suppose this is 1, this is 2, this is 3 by 2, this is 1. So this is minus half, this is half, so this is half. Now we can get a v at x equals to 1, but you have to remember that for mod of x minus 1, when phi x is mod of x minus 1 for x less equals to 3, thus domain for the graph for mod of x minus 1 is from minus infinity to x equals to 3 by 2. So we have the graph look like this. And note that we have sketched the graph of mod of x minus 1 by shifting the graph of mod x by to the right by 1, and we also restricted the domain of that graph by for x less equals to 3 by 2. In similar way, we can sketch the graph of mod of x minus 2 for x greater equals to 3 by 2, and the graph should look like this. So graph look like this w. This is how the graph of phi x look like. Note that in both cases we have shifted the graph of mod x to the right. In the first case we have shifted by 1 unit, and in the second case we have shifted by 2 unit, and restricting to their domain we have sketched the graph. Now clearly this function, this is graph. This is a graph of phi x. Now clearly this function is continuous. You can see clearly at the looking of its graph, and it has 3 corner points. Corner points at x equals to 1, x equals to 3 by 2, and x equals to 2. And you know that if the graph of a function has a corner point at some point, the function is not differentiable at that point. So in this case function is not differentiable at 1, 3 by 2, 2, but since it is linear on other points, it is differentiable at other points, and this proves that the function is continuous everywhere, but not differentiable only at x equals to 1, x equals to 3 by 2, and x equals to 2. So we can say that option 4 is correct.